Hello everyone, welcome to day 3 of logic building in JavaScript. Today we are going to solve a simple problem on sum of diagonal elements in a matrix. This is one of my favorite questions. I was asked this particular question in an interview. I wasn't able to write the code efficiently. Then I came to know about something called DSA. Before that I have no knowledge of DSA. So you can say my DSA journey was started with this particular question. So let's first understand this particular question. Let's say we have a 2D matrix. You can assume this as a 2D tuple or 2D array as well. In this particular matrix, there are 3 rows and 3 columns. In this case, the elements are 1, 0, 4, 0, 2, 0, 3, 0, 3. What we need to do is, given this matrix, we need to calculate the sum of the diagonals. First of all, we need to know that in a matrix, there are mainly 2 diagonal. One is primary and one is secondary. In this case, primary diagonal are these elements and secondary diagonal elements are these. So what we need to do is find the sum of these numbers. In this case, in case of primary, the primary sum will be 6. How this 6 came is 1 plus 2 plus 3, which is equivalent to 6. Similarly, in case of secondary axis, we need to do is do 4 plus 2 plus 3, which is equivalent to 9. So the output should be 9. So let's see how we can solve this particular question. So let's first do the brief crash work of arrays and 2D arrays. In case of Python, list and 2D list. So array are basically group of elements which are given a common name. Let's say we have an array with 3 elements, 1, 2, 3. We use 0, 1 and 2 as indexing. ARR is the array. Array is represented by group of elements. For accessing each element, what we need to do is use something called index. Index always starts from 0 and ends to 2. To access this particular item, let's say 2, what we need to do is name of the array ARR, square bracket and 1. ARR is the name of the array, 1 is the index of this particular value. Similarly, in case of 2D array, what we need to do is, let's say we have a 2D axis. Let's say we have a 2D list. Let's assume 3 by 3 for our case. 2D matrix can be represented in this particular format. Let's say this is our matrix MAT. So this is a 2D array in which there are 3 rows and 3 columns. Now our problem statement is we need to calculate the primary and secondary axis diagonal sum. So to do this, let's first understand the indexing in this particular case. In case of matrix, what we need to do is to index the particular value. Index will be 0, 0, 0, 1, 0, 2. Similarly, 1, 0, 1, 1, 1, 2. Similarly, 2, 0, 2, 1, 2, 2. These are the index which we will be using. So to find the sum of primary axis, what we need to do is find the sum of this one and this one. Similarly, in the case of secondary diagonal, we need to find sum of this one and this one. So let's first look into the primary diagonal. Now let's understand this for the primary diagonal. For the primary diagonal, what we need to do is find the sum. Let's populate the values here. 1, 2, 3, 1, 2 and 3. Similarly, 3 and 4 on the remaining box. 3 and 4. Other are basically zeros values for now. So what we need to do is find the sum. Sum will be 1 plus 2 plus 3. And to find this particular one in programming, what we need to do is, let's say our matrix is mat. What we need to do is mat square bracket 0 square bracket 0 plus mat of square bracket 1 1 plus mat of square bracket 2 2. So primary axis can be calculated. So we need to find a way by which we can iterate to this particular loop. Similarly, for the secondary axis, let's understand this one for secondary axis. For secondary axis, what we need to do is do 4 plus 2 plus 3, which is mat square bracket 0 and 2 plus mat of square bracket 1 and 1. Similarly, mat of square bracket 2 and 0. For primary axis, finding the primary sum is pretty straightforward in this case. To find the primary sum, what we need to do is, if we have a nested loop, let's say we have 2 for loop for I that will range from 0 to 2 and another loop j that will iterate from 0 to 2. What we need to do is, whenever I and j is equal, what we need to do is find the sum. So if I is equals to j, what we can do is, let's say primary sum is stored in p. Initially we set the p value to 0. P plus is equals to mat of square bracket I square bracket j. Now our problem is perfectly solved. We have created the sum. We have found the sum for principal diagonal elements, but this is the unoptimized solution. So what we need to do is optimize it. So first let's see why this is not the optimized solution. In this case there is a nested loop. For I, that I runs from, let's say, 0 to n minus 1. Similarly for loop that runs from 0 to n minus 1. If we found the number of times this particular loop runs, the inner loop will run for n times. Similarly outer loop will run for n times, which is equals to n into n is n square, which is also known as n square complexity. So where this will create a problem is, in our case we are running only 3 elements in the matrix. Let's say there are 3 rows only. The complexity will be 3 into 3, which is 9. But in case of databases and huge application, let's say there are 10 power 3 rows. What we need to do is run the loop 10 power 3 into 10 power 3, which is equal to 10 power 6 times. This is computationally expensive. What we can do is convert the n square complexity into n, meaning we can convert 2 loop into 1 loop. What this will do is, instead of running loop 10 to power 6 times, it will optimize the solution to run the loop only once, which is 10 power 3 times. Let's see how we can solve this particular problem using 1 loop only. So to solve this problem, what we can do is, let's take this example. If we see our indexes, what we are going to check is 0 0 1 1 2 2. So basically first and second value is always equal. So what we can do is, instead of running 2 loop, what we can say, for I in, let's say for I that runs from 0 to 2, what we can say is sum plus is equals to mat of square bracket I square bracket I, which will result in mat of square bracket 0 0, mat of square bracket 1 1, and mat of square bracket 2 2, which will result in same solution, which is 1 plus 2 plus 3 is equivalent to 6. So instead of learning loop twice, what we can do is find the solution in 1 loop. So this is called optimization, which we can do by finding time complexities in the problem. Now let's move that back to our secondary axis. In this case also, first we will find the solution using 2 loops, then we will try to optimize it for 1 loop. So to find the solution using 2 loop, what we will do is have a 2 loop for I, which will range from 0 to, let's say, 2, another loop that will run from j to 0 to 2. So if we see the pattern here, 0 and 2, 1 and 1, 2 and 2, we can find some kind of relationship between them. If we find sum for each case, what we can say is they are always equals to 2. So what we can do is write if condition, I plus j equal to 2. Then what we can do is find the p plus equals to mat of square bracket I square bracket j. Let's furthermore understand this question. Some might feel confusion here. Let's say all the elements iteration will be 0 0 0 1 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2. So these are all the indexes of 2D array. What we need is only 0 2 which sums to 2, 1 1 which sums to 2, 2 0 which sums to 2. Rest all are not equal to true. So this solution will give us the best answer. Now another question is, this is still optimized because there are 2 for loop here, for I and for j. This also create the same problem. We are learning the loop twice. So to run the loop only once, what we can do is, what we have done is there is basic math here. what we have the condition is I plus j is always equals to 2. What we need to do is eliminate this particular j. What we can do, instead of writing j, what we can do, j equals to 2 minus I. So using one loop, what we can do is instead of j we can use 2 minus I. So create a simple loop here for, let's say, I that iterates from 0 to 2. What we can do is p plus equals to mat of 0 and square bracket 2 minus I. How will this solve the problem? Let's say I value will be 0, 1, 2 and 2 minus I value will be 2 minus 0 is 2, 2 minus 1 is 1, 2 minus 2 is 0, 0, 2, 1, 1, 0, 2. So this will also result in our case, I think 4 plus 2 plus 3, which is equals to 9. So by this way we can solve this particular question. So writing the both code together, what we can do is, to solve the both case, what we can do is write one for loop answer for this. Let's start with two for loops and then move into single loop. Now we have statically used here 0 to 2 here, but let's say our problem statement increases and number of dimension increases. What we can do is generalize this particular questions for n. So instead of 2, what we can do is represent this in n. In our case there are 3 by 3 matrix, so what we do is represent n by 3. So for the loop, what we will do is, for let's say I in let's do range, what we can do is n is 3, so iterate for 3. It will run from 0, 1 and 2. Similarly for the inner loop, what we can do is j in range 3. This will also run from 0, 1 and 2. If we print I comma j, what we will get is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So let's remove this code. And for the primary sum, what we need to do is, let's say we do p is equals to 0 and secondary sum s is equals to 0. We write the code here if I is equals to j, because for the primary axis the first and second index is always equal. So what we can do is p plus equals to let's say m is our matrix I and j. Similarly for the secondary axis, what we can do is do if condition. We cannot use else if condition, because if we use else if condition, the center point will be avoided here. So what we can do is, if what we need to do is I plus j. Initially we have done 2, but let's generalize this particular 2 into n. In this case n is 3, so we can represent 3 minus 1, so n minus 1. So this will generalize for all data, and we can do s plus equals to m of I and m of j. Now this can solve the problem, but again as we discussed, this has complexity n square. This is unoptimized solution. To optimize this particular solution, we can do let's say we can write n here, because we have already optimized for a dynamic value, not static value. So this solves the problem but had n square complexity. Let's reduce this complexity to n. So to do this, what we need to do is create a for loop. Let's say for I in a range of n, and we have n value 3, primary equals to 0, secondary equals to 0, and L will iterate from 0, 1 and 2. For the primary sum, it is pretty straightforward. What we can do is p plus equals to m is our matrix, square bracket I and I. This will do 0, 0, 1, 1, 2, 2. Similarly for the secondary axis, what we can do is s plus equals to m. We have already done I here. In case of secondary axis, what we did here is 2 minus I. So 2 minus I can be represented in terms of n. 2 minus I is equivalent to 3 minus I, which is equivalent to n is equivalent, and 3 is equivalent to n, so n minus I minus 1. Again rewrite as n minus I minus 1. So what we can do is write here n minus I minus 1. So this will solve our problem. It will iterate from 0 to 1, 1 and 2, to 0. So this will solve our problem in one loop. This is the optimized solution. So let's jump into our code editor and see the solution for this. Let's copy our data from here. This is our matrix. So what we can do is, let's start with the Python code here. Let's say I have a matrix equals to this particular element, and what we need to do is, let's do the unoptimized solution first and then move into optimized solution. We can say create n is equals to len of matrix, and we can do for I in a range of n. Similarly repeat this for j, and for testing purpose let's do print matrix square bracket I square bracket j. Let's do python 3 test.py. Yes, it will print all the elements. Our condition is, whenever there is a primary axis, what we need to do, if I is equals to j, if I is equals to j, we need to create variable here. Let's say primary underscore sum equals to 0 and secondary underscore sum equals to 0, and we will do primary sum plus equals to matrix square bracket I and j. Similarly, in case of secondary diagonal, I plus j is equals to n minus 1. We can get secondary sum. We can print primary sum and secondary sum. Output should be 6 and 9. Let's run this. We got 6 and 9. So what we can do is create a nested loop, if condition, and find the sum. But this is not the optimized solution. This has n square complexity. Let's find the optimized solution. For this we will be needing only one loop, and what we will be doing is primary sum plus equals to matrix of I and I, and similarly for the secondary sum we'll be doing n minus I minus 1. Let's save this. We still should get the same answer. We got the same answer. And if you want to solve this particular question in a Pythonic way, what you can do is directly use equals to sum, which does the sum for all the elements in a list, matrix I for I in a range of. Similarly, you can do same for secondary extent. Instead, you will have to do n minus. Let's save this. Let's run this. You will still get the same answer. So this is the Pythonic way. You can use this built-in function to find the solution as well. So by this way, you can solve this particular question in Python. Let's quickly do this for JavaScript as well. JavaScript is pretty straightforward. So we have initialized the matrix, n equals to matrix dot length, and what we need to do is, for primary sum, let primary underscore sum equals to 0. Similarly do secondary sum equals to 0. Create two loop. Let I is equals to 0. I is less than, let's say, n. I plus plus. Similarly do the same for j, and keep the condition here. If condition, if I is equals to j, we do primary sum plus equals to matrix square bracket I square bracket j. Similarly, for another case, what we can do is, if I plus j is equals to n minus 1. So 2, we have converted 2 into n minus 1, and do the console log here, primary sum and secondary sum. If we do node test.js, we got 15 and 0 here. There should be secondary sum here. Let's rerun this. We got 6 and 9. And again, to get the optimized solution, you can use one loop only. So let's comment this out and paste this. So we can remove all the remaining codes here. Remove this, and what we can say is I and I and n minus I minus 1. Let's save this, node test, and we will still get the same solution. So this was our video regarding the problem solving session on the diagonal sum. I hope you like this video. This is a pretty basic, easy type of question which you will be learning. In the future, we will be slowly increasing the difficulty as well. Let me know which type of questions do you want me to solve in the future. I hope you like this video. See you on next video.